expected 2 years ago, but some small things changed the world, especially for us. And even we expect 200 people coming. The most important are there. You are there. Some are also in a NAPCOR session this morning, so they are not with us, but they will come this afternoon for the common session with other part of NAPCOR, but very linked to DATEX II for parking and for TNITS and traffic regulation. And that will be two very interesting topics. Then Joseph will present, and Bart also will lead these two sessions this afternoon. We had also another big competitors in Paris this week, because, and that is perhaps some are not attending DATEX II, it's international professional games for IT conference. And so we have now a very interesting topic for us, sharing data for traffic digitalization. That is also part of the future, like games, but it's not games, it's real world. And so I let you the floor now, Bart, as the leader of this sub-working group 4.1 of NAPCOR, DATEX II, and we will go inside this DATEX II standard, entering by DATEX II for Dummies.
Yeah, that's a bit with this crowd. DATEX II for Dummies is a bit, well, water to the sea or preach to the convicted, whatever. Well, welcome. As introduced by Jean-Philippe, thank you for your kind words. My name is Bart de Vries. I'm chair of the DATEX II group, DATEX II organization, we used to say in the past, and I think we still stick to that. What I will do is I give you an overview of what DATEX II is actually, what it is intended for, and how it fits in the current developments of data provisioning in a regulated context of delegated regulations in combination with other standards. And normally if you do a big conference, you have the nice managerial talks, the keynote speeches that that set the scene, but these keynote speeches will be in the NAPCOR setting. So this introduction is just to set the scene. The keynote speeches are in La Défense, and we will be connected to those speeches via the screen. And that gives you a better overview or a complete overview of what's happening in terms of the data generation and discussions that that we have around the data provisioning as a total. We offer the toolbox to deliver the data, to understand the information that is offered, and from there on to create services based on that. Well, like I said, I'm Bart de Vries. I work at the National Road Traffic Data Portal in the Netherlands. I'm lead architect there. The National Road Traffic Data Portal was formerly known as NDW, which is it's a much better acronym to use. And we are one of the data hubs in the Netherlands that offer data that is made accessible via the national access points. So in essence, NDW is not a national access point, but in real life it is considered to be the access point because it's where the real data is. Well, what we are talking about with DATEX is not about the infrastructure. We don't address the infrastructure. That's why we have the Red Cross. But we talk everything that's happening on it. And it's about traffic, it's about the accidents, it's about measures taken, it's about counting vehicles, etc., etc. And that all fits in an ecosystem of mobility information that serves the users to, I can better look at this one, that serves the end users to make decisions on their trips in a multimodal setting. And that is partly regulated, where we have the delegated regulations on real-time traffic information that is revised, and the revision becomes active per the 1st of January 2025. And we have the multimodal services, and we have also the RTTI, the SRTI, the safety-related traffic information. Well, in these regulations, there are around 70 data categories mentioned of types of data that have to be provided if you have that data. And there are conditions, and we're not going into the conditions, we are talking about the information that is in these data sets. And each color is representing one of the data categories in one of the regulations, which varies from address information to whether safe and secure truck parking is available, and the truck parkings are whether there are places available. And that's a wide variety, also charging points, etc., etc. And they all have a location in common. And there are other concepts that are there as well: tariff structures, payment structures, vehicle characterizations. They pop up in different categories, and that's why we have, but they all come up in different domains. We have the public transport domain, we have the road traffic and travel information domain, and air and rail are addressed. But these are not covered by DATEX. DATEX is only about the road traffic and travel domain. And but we have overlapping concepts with the other standards as well, which are in the public transport domain. And public transport is not only addressing the timetables and availability of buses and pricing and tickets of that, but it also addresses how you can connect to the how you can, as a traveler, make your trip using all these different modes. So it's not only addressing the public transport services as such, but it is also addressing how to use them and how to connect to them. And what we see is that in the road, we see also overlaps on the functional level, because roadworks and parking could affect each other. Charging points and parking are narrowly related. So this is all in a wide picture of a coherent set of standards. And the road traffic and travel domain is covered by the DATEX II standards. This is the overview of the core standards, the reference standards for the entire series of the delegated regulations. It's about DATEX II, road traffic information and traffic data, TNITS. It's about map updates, static data as it is called, but this is not a really nice differentiation or separation of concerns, because we have overlaps, which is also depicted in this schema, and we have the transmodal NetX and series standards, which are for the public transport ecosystem. Well, we have the information challenge and the interoperability issue. I have a plug and I have an outlet, but they don't fit to each other. And especially if you have several plugs from different countries and only one outlet, then we all, yeah, we tend to have forgotten, but we all used to travel with these converter sets, which was not very convenient. The standardization of this plug was really a benefit, and it was achieved because of European intervention on the standardization of plugs. And exactly the same is now going on with the plugs for the telephones and so on. Everyone needs to have a no USB-C connector from next year on or something like that. And everyone has to publish its data in one of the core standards or fully interoperable, or you can plug it in even if it is not exactly the standard, but it has to be processable with the same kind of data. So what is DATEX II? It is the E-language for the coherent provision of road traffic and travel-related information. And it is addressing all road networks. That is something which is not so obvious because we started as a standard for the exchange of information between traffic control centers of motorway operators. And that's a very limited scope, we would say, nowadays. At that time, it was the world, life, universe, and everything. But nowadays, it's bringing a lot of additional requirements, especially the urban setting, where traffic management is not so much focused on traffic, but on public space management. And that is a different way of thinking about traffic. One of the key elements of the DATEX II standard is that it is maintained by the stakeholder community, especially by the community that provides data, that wants to convey a message to others to achieve a certain outcome on the road. All this work is standardized in CEN, Working Group 8 mainly, and the exchange layer is going to ISO. But we see that the ISO standardization is getting bigger and bigger because a lot of the issues that we address are also addressed on a global level. And an interesting development, though it is still a small step, but DATEX is also used in Colombia nowadays. And maybe it's used in other parts of the world as well, but at least the situation publication is implemented in Colombia for providing information about roadworks and other road incidents. DATEX II gives you flexibility if you are a data provider and there are things missing in the standard that you want to include in it. There's a mechanism that you can extend the model with a local addition, and that enables you to be still interoperable with what is used in the rest of the world, but you can add those special things that exist in your setting. Well, and DATEX is like a natural language. It's about grammar and a dictionary. So how is this standard organized? We have traffic situations, so the incidents that happen on the road that affect the normal use of the road. We have traffic status, which gives you the data about what is going on the road in terms of flow and travel time performance, like that. We have the traffic management support. Road operators tend to influence what's happening on the road. They close lanes, they have diversions, they reduce maximum speed, and what have you. That's very well supported. We have the messages displayed on the VMS, which is the variable message shields. Some countries, they call it drips. We have service information, so whether there are disruptions in service that is services that are available around the road. There's a huge effort in the parking domain done the last couple of years. First started with truck parking and then also on and off-street parking for person vehicles. We support the urban use case nowadays much stronger. And we also do energy publications, which is about charging infra and its real-time availability, and alternative fuel infrastructure and its real-time availability. We also started, no, it's even there nowadays, the traffic regulations, so the digitalization of traffic regulations and their real-time activation in the road, on the road. And a special treat of that is the urban vehicle access regulations, which is the low emission zone, limited traffic zone, congestion schemes, pedestrian zones, and zonal parking spaces. Well, now what does DATEX do? Well, DATEX II is when you win the Eurovision Song Festival and you have really an award, you've won and you want to tell your grandmother. How do you do that? Well, you need a language and you need the words and you need the grammar to understand. You cannot call her, it's not by speech, so you write her a letter. And that letter is on the mailbox, and then there is a transportation system that brings the letter via the postal office to the mailbox of your grandmother, and she reads and she understands. And that's exactly the intent of DATEX II. We want to convey a message, we bring it to the postal system, and the postal system is standard IT in DATEX. And there are a lot of postal systems. That's a lot of discussions are about the postal system, not about the grammar, not about the dictionary also, but we tend to lose ourselves in the discussions about the postal systems, and we don't care. DATEX II is the letter, it's the language and the paper, and we use profiles, so to say, which gives the formats of for specific purposes, like roadworks, or like traffic flow, or like charging stations. That's all in profiles, predefined to have a to support standardized implementations all over Europe. And we have DATEX II Lite, which is a simplification. It's not a simplification. It's an easy, digestible format with limited technical capabilities. So it is only addressing the use case of presenting information directly to the end user. I'll give an overview of how that fits in the ecosystem where DATEX II is applied. The postal, like I said, the postal systems that we use are standardized IT, and we have the envelopes defined in XML structure or JSON or ASN.1, whatever is preferred by the data provider. And we do pool services where I have to say that the web services are the more mature, but also getting deprecated in some settings. So we go more to the open API, and we are also exploring message brokers and stuff like that. And then there is the difference between pull and push, because we are working in a safety critical environment in certain use cases where timeliness is key, and then the push is recommended because it gives you instantaneous updates of what is happening on the road. And we separated concerns. In the past, DATEX II had content and the postal system in one complete approach. That is not very robust, so we separated those two, and then it gives us the opportunity to develop other technical exchange platforms with the same content. And that's one so that we can use a combination of very old and very modern techniques. Well, why do we standardize? The standardization is to avoid the asynchronous interfaces with a lot of risks in terms of loss of information, difficulties in interpretation, and the implementation costs. Because if you have several types of interfaces, the costs of implementing them and maintaining them over time is very high. So standardized interfaces also are beneficial for the business. What we encounter a lot is that we have community or data providers that only have one interface to the outside, so they don't have that issue because this is my data. And the fact that they have colleagues providing the same kind of data, also with their own interface, is a nuisance for the receiving side because they have to support all the different flavors. And one of our key challenges is that we have to convince everyone that you use the same language, not for your own sake as well, but it is mostly to have an easier adoptance process at the receiving side. So if you provide it in a standardized way, the chance that service providers really consume your data is increasing. That's sometimes very poorly understood, and people are not aware, but they create this kind of infrastructure. And that's the will to collaborate can avoid this kind of mess. The local adaptations I mentioned, the funny thing is that some of the local adaptations ended up in standardized solutions now used all over Europe. The fuel pricing extension in Germany was created because of a German law about the providing that data within, I think, seconds after they change, minutes, 1 minute. That's 60 seconds, that's also second. That's to provide that data in a standardized format on the German data portal. And that extension actually was the first step to the energy publication that was accepted as a cent part in last year, I think it was Jurgen. Yeah. In the Netherlands, we have a very remarkable construct with hindrance. The amount of hindrance a roadwork is causing to traffic in terms of number of people affected by it, the delay they experience, and it is used to categorize the work and to align roadworks with the different road operators, that they don't do hindrance type alike roadworks at the same time. So people always have an alternative. That's a very local requirement which supports the typical process in the Netherlands of managing the roadworks planning. That's not ever gonna come to the European level, is my expectation. So this is a very typical local extension to the roadworks information that is only used in the Netherlands and will never come to the European level, but it is very useful for us with regard to the management of the roadworks planning. We also started with location referencing, extending location referencing. OpenLR was developed with TomTom and the Swedish National Road Administration, and it is now part of the standardized, one of the standardized parts of the Netherlands. and traffic management plans. It's a story. I think it starts 1998 or something. Traffic management plan exchange between traffic control centers in cross-border. That's really old, but it is really, really actual at the moment again, with the dynamic traffic management of collaborating traffic management organizations to have an integrated approach to managing traffic. So where do we come from? I spoiled it a bit. We started as traffic control center to traffic control center. And that's the interface, that's the zero, the year zero. Really quickly, the scope of the use of DATEX was extended to providing data that came from the traffic management process and traffic information to provide it to what we call big service providers. Why do we say big service providers? It's not because they are tall, but they have a substantial system capability to digest the data that is provided and convert it and ingest it in their services to the end users. And that's in the apps. And whatever an app is, doesn't matter. It's the end user service that is used. And that line is service provider specific. There are standards there, but they are not in our scope. Nevertheless, we align with them because we want to ensure that the message that is intended by the data provider ends up well in their end user environment. But we found out that we have small service providers as well. They don't do much with the data. They don't want to integrate it in navigation solutions or other smart processing of the data. They just want to convert it into something that is presented to the end user directly. And that's a different use case. And it is, although we thought in the beginning that we would have more and more big service providers, we see that the use cases are getting more and more to the simple services that the consumers of our data expect it to be ready for insertion in the services provided. And that's a development we didn't expect, let's say 10, 15 years ago. A new development is the CITS ecosystem. For some of you, very well known. For some of you, it might be just scratching your head a little. What's that? It's connected and cooperative ITS. And that is aimed at having a direct connection from the road operator to the car and end user, and the other way around. It's mostly a technical thing, but it offers also a new way of thinking about data provisioning for road operators. The technology is especially in the developed now for the for alerting dangerous and situations real time on the road, which could vary from you are approaching a low viaduct in the road to there is an roadworks system on the road, or an accident happened just a few hundred meters in front of you. So it is about warning and alerting mostly at the moment. This is not in scope of DATEX, but as you can see, the source is the TCC for some of the use cases there. So the interoperability with that, because the data, it's about the same real world things that happen on the road. The data has to be in the same quality and the same information type. And every now and then we see that traffic control centers want to ingest data into the apps directly themselves. It's not what we where we came from. And this all ends up in the system or the DATEX 2 model as it is today, where we already said DATEX, the interfaces 0 and 1 are the full model, as we say it. DATEX 2 is more for the DATEX 2 Lite and 3. And 4 and 5, they are message-specific protocols, which are outside the scope of DATEX. So how do we see, how do we perceive the world of data provisioning? We have vehicles, end users, and we have the traffic centers. And that used to be a line from where we have actors that are access points where the data is made available from the public sector or the road operators' point of view. Then we have content aggregators. They collect data from different sources. We see the role of service provider and the service access points, which could be, that's a technical distribution point of the data. And some do all these roles, but for the separation of concerns, we identified these to make sure that we are talking about the same thing. Because what we have a lot of architectural discussions also. Who's responsible for what and in what use case is what standard used. But this, it was very, very simple. We had there was no feedback from our data collection done in the past. It was the road operator had the big systems, was the only one that could afford the detection systems that were required. Crowdsourced data didn't exist because simply the technology was not there. But now the world has changed and it has become much more of a circle, and all these all these actors, they interact with each other because they add information they add information because they have access to, they collect data, they have access to data that others don't have, and that brings it as a whole ecosystem, which makes it much more complex. And we see now the need for to support this complexity, because data, you want to add information to already existing information without changing the one, or maybe it does change. That's up to the source, and that complexity needs to be supported as well. That's one of the challenges that we face in the near future. Now, what is DATEX 2 version 3 about? And I watch with my watch. It's a toolbox, and it supports urban mobility, the electric mobility charging infrastructure, and one of the last extensions. The logistics sector is more and more demonstrating that it has different requirements than ordinary traffic management or user. For the logistics sector, is it really important? Can I reach a certain address? Am I allowed to get there in terms of the vehicle that is used? Is the road available there? If I have a one-way street, can I access the address that is in the street? Road operators do not tend to think in addresses, but they think in terms of roads and availability, but how it affects the actual accessibility of a certain specific end location is something in that sector. The digital traffic regulations we already mentioned, and of course the future of connected, automated and cooperative mobility. And then full swing, it's not only about vehicles, it is about all modes. That's to be understood. And in the past we had one big, huge model conveying live universe and everything, but that was a bit too much. So we broke it down into functional packages, and we split off exchange. and the use cases have their own specific profiles. Now, if we look at the standards, and I do this very short because Jörg will give a more detailed overview, but we have the layered approach, we have the methodology that defines the rule of play, how to set up the standard, location referencing, and then the common parts which are reused in all the more specific subdomains, where we have the current state of version 3 and what's coming up rather soon, where we have here still UVAR as a separate publication, but that's not going to happen. It will be part of the traffic regulations as such. Or it is. Well, it's partly standardized in CEN. This is the 16157 series of standards. It has 12 parts nowadays. And we also do standardize the interchange layer, the exchange layer, which is standardized in ISO because the Japanese and the US also has standards on the interchange level of traffic data, and there's an agreement between CEN and ISO that if ISO picks up some work, it's no longer done by CEN. So maybe in collaboration, but that's why ISO is this part of DATEX is in ISO. Well, this is a very big, huge thing, DATEX. And how do you use it? And we have developed the DATEX II Academy for that. And the DATEX II Academy has 4 levels of support addressing the beginners. And what I'm presenting here is the basic material up to the expert level on level 3, where you know how to create the models that end up in the standards as such. And it's a journey. Most of the people that are having to work with DATEX can be supported by the level 1 support that we offer. At some need to do these local extensions, you have to be a master. And if you want to be on this stage, you have to be the expert. How do we do that? We differentiate in focus groups, where we say we have the policy and managerial people that that hear that they or read in a regulation that they have to implement DATEX II. We address those with specific materials. They don't get above or more deepness than the basic level. They don't need that. Then we have the functional people, the traffic engineers, the information managers, and so on. And then we also have the developers that have to develop the systems producing or consuming the data. Well, this is how we are organized. If you have problems falling asleep at night, you could have a look at this one. And now I hope that this one will work, but we have a small movie. Can the... we have no sound. Is there sound possible? No? No sound. No sound. Well, this is the story about something happens on one side of the tunnel, and does the other side know? Because people keep on driving into the tunnel towards the big problem on the other side.
The responsible road operator monitors his roads in his call center. He registers the snow, and for safety reasons, he closes the road. Instantly, above the road operator enters the measure in his traffic management system in his own
and it
Are his partners aware of his measure? DATEX II takes care of that. The measure
logo of DATEX helps in distributing this information to the other side of the border.
The DATEX II messages
Receive the DATEX II
the foreign traffic situation in their language on their own map. When the situation abroad influences local traffic, the receiving road operator takes adequate measures on his road network. Service providers process the DATEX II messages automatically and inform their customers about the incident abroad and provide an adapted navigation instruction. This way, an Italian driver heading to Spain knows that he has to change his route and travel via Switzerland because the road between France and Italy is impassable. DATEX II is the European e-language for registering and exchanging traffic and travel information. It covers, for example,
well, we already addressed that we support a lot of different use cases to help the service provider and road operators understand each other. Well, if you follow all these lines, you will see the countries where DATEX II is implemented. And most important, we want to be an open community where everyone who has an interest, whether it's on the service provisioning, on the data provisioning or the data consuming side, to have the opportunity to bring in their requirements and to discuss with us. And we also support each and everyone who is having problems via our support organization, because DATEX II will we are a bottom-up organization where we want to support the real users. It's not an academical research approach, though we are based on very sound methods in the data modeling approach, but we think that this helps in creating a more safe, greener, and efficient transport system in Europe. That brings us this first introduction of what is DATEX II about, brings us to what is this user forum about. And we are now in the opening and DATEX II in the NAPCOR project. The next one is going to be Jörg, who will do a walkthrough the data model of DATEX II in more detail. Then we, at 11:30, we will connect to the plenary. And this afternoon, we have several people will come from La Défense to here to have joint sessions, especially on the traffic regulations and UVAR, which is the new kid on the block, so to say, traffic regulations, the regulatory context of a lot of information that is conveyed via DATEX has a regulatory context, and that needs to be expressed more and better than we used to do in the past, because of the trust and authenticity and also the legal impact of using the data. Joseph will guide us through that. In parallel, we also have a very interesting session. If you have a DATEX II version 2 data provision, how can you upgrade without replacing your system to the version 3? So offer the data in the DATEX II version 3 model, but also the technologies. If you want a JSON interface, you have to do it in version 3. That's the first set of parallel sessions. And then after the break, we do the real-time traffic information. This is the RTTI interpretation or session, where we will present how the standards, and it's not only the DATEX II standard, it's also the TNITS standard, how they support the different data categories in the RTTI data provisioning, with some deployment examples, best practices from several countries. In parallel, we have a session on parking, the parking data publications. They are done in collaboration, they are developed in collaboration with the parking operator sector from the EPA, the European Parking Association. And they have initiated the Alliance for Parking Data Standards. That's a global approach, but to make sure that the traffic management viewpoint on parking and the parking operation are well aligned, because parking operation is in a lot of use cases also a public interest or a public activity. There was a good reason to have this alignment established. And in parallel, we also have the CITS, which I showed you how that fits into the bigger picture, and the relation with DATEX II, and how these two have can benefit from each other's developments, and now and in the near future, to support the joint interests. And then after that, we opened our club, the club DATEX II, this evening, where short pitches will be made for some interesting, with a very specific scope of interest, to demonstrate what's going on in the world of systems and new use cases that are supported by DATEX, and some deployment examples, and all this in combination with some nice snacks and an enjoyable drink. So a real good club experience, we think. It's such a good thought that people from La Défense all are jealous and will come over to join us here tonight. Then tomorrow we have two more DATEX II specific sessions. The first is in parallel. There we have the safety-related traffic information. One of the key elements of safety-related traffic information is that it is timeliness, that is unambiguous, and that it is in all standards well supported and understood. And jointly with the people from TISA, the Travel Information Service Provider Association, the C-Roads community, we have done a big effort to ensure that this interoperability across the standards is there, and we will even extend that in the near future. And then it is then in parallel we also have the session on safe data exchange, safe and secure data exchange, which is addressing trust and data authenticity, cybersecurity aspects of the DATEX II specific data, or maybe you should say the information, and what is needed to do that in a safe way, according to the new views on that kind of or on that subject. Then we will close our session with a panel discussion about the future of DATEX II. We will have some pitches. We will have the panel here of the experts. Average age is close to the pension age, but that's also one of our concerns, that the continuity. And we have our 7th DATEX User Forum today and tomorrow. We start the DATEX standards started in the 90s. DATEX II started early 2000s, but we are now 20 years further, and people retire, and that's fine. But the need for the standards stays, especially now that they are mandated in a legal context of the delegated regulations. So we address the future of DATEX II, and we want to interact closely with the audience, with their thoughts about what's needed in terms of whatever concern there might be around DATEX to now and in the bit further future. Then we will switch on the big screen and the connection to La Défense again to have the closing ceremony of the NAPCOR event as our joint closing. And after that, we will have lunch here, and you are free to go back to your normal life. So thank you. And I would like to give the floor now to Jörg. It's easy.
Okay. Yeah, thank you, Bart. I'm not sure if there is need for a break or not. I don't know. Any opinion on that, or shall I just continue? Is it correct? We end at 11. So. Yes. Okay, so it's more than 1 hour. That's. We will see. I don't think that I need that much time. And of course, I see a number of familiar faces here in the room, and I fear that I cannot tell you anything which you do not already know. But Bart encouraged me that there are also people that are interested in the basics, and that's why I want to tell you something. Actually, my presentation, I think that was my task to tell what is new in the upcoming new version. Bart now introduced me that it is a walkthrough through the model. I will do that. I will not have everything on the slides because I will talk a little bit on the model contents. And as I said before, it will be some basic information that you get here from my presentation. I will start my presentation with numbers, some important numbers in the context of DATEX II. And these numbers, as you can see here, in my opinion, these three numbers which are important. And maybe it's a trivial thing, but I think it's important especially for newcomers and for people who are not too familiar, to explain this and to have that clear what it means. Yeah. Because we are always talking about DATEX Roman II. And that's always what we mean. And usually when we talk in an unfamiliar way about DATEX, we do not mean DATEX without any number. It existed in the past, but it was in the very past, as Bart already said. It was before the 2000 years. The very first version of DATEX had no Roman number in behind. But that's long ago, and so whenever we talk about DATEX Roman II is meant. Now 3.4 could be new for you because it's a version which does not yet exist, but it's the version which will come into force it's planned for end of this year actually. That means here we are, of course, in the Arabic numbers. The major version 3 you have certainly heard about, and now we are on stage 3.4, which means that the right current version is 3.3, of course. And of course, these major steps are always very important because, of course, there was an Arabic version 2, DATEX II version 2.3 was the last one. And we also have a session this afternoon where we again explain what have been the changes between those two major versions of DATEX from the Arabic 2 to the Arabic 3 version. And then we have this ominous number here, this 5-digit number, which you might have heard if you are in our DATEX community, because this is the number of the CEN standard. The DATEX CEN standard at the end. Yeah. It's CEN technical specifications, and it's also a European norm because it's a multi-part standard. We have a lot of parts in this standard, and I will show them now in some list. Bart already had a quite nice image of all these things. I have a ordinary list form, but yeah, I will explain those now. And maybe one more thing, whenever you hear the spelling DATEX 3, of course it's not DATEX Roman 3. Yeah, it's DATEX II version 3.x. Yeah, as I said before. Okay, even more numbers. Now I'm coming to the standardization part of DATEX, and yeah, this is the ominous number 16157. It's a European norm for some of the parts, and here we have the three very first parts which have become a European norm in the past. In the past there have been technical specifications, and then there was a switch, and when they have been revised they became a real European norm. And this is part 1, context and framework, part 2, location referencing, and part 3, situation publication. I have no detailed slide for that, but I think it could be worth to mention what is in these models. Yeah? The first one is, I think, the only part which is not directly content model related, but focusing on the methodology. Yeah, it sets up the scene for all the other parts. All other parts, of course, refer to this methodology part 1. And it defines the UML, the use of the UML in our models, and defines all allowed techniques and methodologies for the content parts which follow in the next numbers. Location referencing, but already listed them up, which we have. DATEX does not define own location reference methods. It's nothing invented by DATEX. DATEX only refers to existing things on the market, as you can say. Yeah, OpenLR, GML, of course, trivial things like coordinates. We have this ALAT-C still on board, and TPEG-log, which is an older format for that. And some ISO, some ISO location referencing methods for linear objects. So all these things are implemented in DATEX. All these things can be used in DATEX. And of course, as you can imagine, it's widely used because whenever you want to communicate some relevant traffic information or whatever, you always need a location reference. You need it everywhere. And you have the full variety to take use of it. Situation publication is a quite important publication because it's a wide field what you can express with it. You can express things like operator actions, like roadworks. You can refer traffic situations like accidents or traffic jams. You can give some information about weather conditions and things like that. Altogether, it's called a situation and a situation record. We always have in DATEX this kind of database speech which talks about tables and records, and that's why we have a situation record here on this element to define these things, yeah, as I said, like roadworks and traffic and non-traffic related situations. As I said, these are the first three parts which have been the first parts. Of course, situation publication is a quite old, or let's say a model with a long history. And I won't say it's outdated, but there are issues where situation publication is not the best solution for information we need in the future, and we will come to that later. Has to do with traffic regulations, because the mindset behind situation publication, yeah, is a little bit from the past, of course. We have some more parts, 4, 5, and then you see 6 is missing for a certain reason, and then part 7. VMS, of course, is an important part of the DATEX standardization. The variable message signs, everything which is dealing with images shown on the road, near the road, or whatever. In our days, also talking about virtual signs, etc. Of course, these parts have been revised, and especially VMS publication was revised into the European norm, and there have been a lot of changes to make it fit for the future, using the graphical data dictionary from another standard. And yeah, it's a quite big model to express everything you need for images and messages on the road. Part 5, messages, measured and elaborated data. Well, everything you can measure, raw data, elaborated data, everything you want to transfer on a base of real measure values. Yeah, you have basically two options. As it is described here, yeah, measured and elaborated. They are quite the same, but with little differences. Also, this publication has been revised. Now it is possible to have more element values within one turn. In the past, there was only one value allowed, and now you can adjust the physical quantity to a larger number. That's what is new in part 5. Part 7 has to do with the new DATEX version 3, because, like you know that from other languages and ecosystems, there is a need for some element which encapsulated things you always reuse. Yeah. In the very past, we enabled it, reused classes, reusable classes. In our days, we have a new standard for that, which says common data elements. And you find things in there like vehicle types, like timing issues, validity elements, vehicle characteristics. Yeah, everything which is not too much specific for one use case, but for more or less all use cases or a number of use cases. Yeah, I said there is missing part 6 here. That's because we are talking about the European norms, which have which is of course a quite good label to have a European norm on that. And the next elements here are on the level of a SEN technical specification, which means, of course, they can make it into a European norm, but that's to be decided in the future revisions. And there we will start with part 6, with the parking publications, which deals about parking, of course. I will explain these things later on a little bit more detailed, so here I can be a little bit shorter on that. But whatever I can say is part 6 is revised and was published in the latest version now in 2022. And it's a very interesting thing. Yeah, but I will talk a little bit more on that later. Then we have part 8 and part 9. The interesting thing on these two parts is that they have not been developed by, let's say, by the standard working group, which is standardizing the DATEX parts. The standard working group would be working group 8 in SEN 278. And these have been developed by working group 17, so by another working group. Not by chance, but by some, it was called an expert project group. They had a real looking for experts who should do that. So the experts came together and made these two standards by they had a task to do that. Yeah, let's say it like this. Nevertheless, they integrated it directly in the correct series, which is a quite good thing. And of course, they use DATEX mechanisms. It's a real ordinary DATEX parts which have been created there. And yeah, as you can see here, it's one part which deals especially on the urban environment, including rerouting, and part 9 is a part dealing with traffic signal management measures. Also for these parts I will come into details more later. Quite new parts are the energy infrastructure publication and the publication of machine interoperable traffic regulations. Also, I will tell later more about that. And facility-related publications. On facility, I can say this is it's a thing quite comparable to common, because again, it's a collection of things which can be needed by other parts and by other models. It's not so much directly related with traffic-related issues, but with facility-related issues. We're talking about opening times. We're talking also about rates nowadays and things like that. That is collected in this part number 12. You see some asterisks here. That means especially part 8 is under revision, and part 11 is currently under revision. That means in the NAPCOR project we have work items for that to update to update the data models. Of course, the standardization is a step, is a later step, and has to be taken by the corresponding working group. And especially for this part 9, well, there are decisions outstanding how to proceed with this part 9. That's not clear. There are different options what to do with it. Then there's another one. It does not have any number right now. Maybe it can be part 13. The problem is that it has a completely other number, because it was, this part also was developed in another working group, in this working group 17, in another project team, which is called Status, Fault, and Quality Requirements, and enriching the standard about a more detailed fault model and a more detailed status model. Of course, DATEX has status and fault information, but not at the detailed and enriched level. And now the idea is to get rid of this number, which is some arbitrary number, and to integrate it into our DATEX series. That's the plan right now. And then we have a standard. Bart already mentioned them. Bart had another standard from the 14,000 series, which is not on my slide here. And that's about, Bart called it the postal system, the exchange. It's an ISO standard, and it deals with the platform-independent model specifications for data exchange protocols for transport informations. That's a kind of, of course it's related to DATEX because it specifies things which are very useful for DATEX. DATEX introduced the option to take this Exchange 2020 model for data delivery. And as Bart said, this is not the content side, this is a postal office side. And on this presentation, I will not go into details on that one. Now we do not make a switch, but it's another level of things, because I talked about standardization, and one of the, I think it's a quite big problem, is always to keep standardization and DATEX as such in line, because these are different paths we have to go. And you already learned that we, of course, have some version on DATEX. I'm here starting with version 3.2. Of course, there are versions before, but I'm starting here. I learned from Ian that maybe I made a mistake, and some of the elements already have been in 3.1, but that shouldn't matter here at that point, whether it's one version before or not. You will find more or less the same elements here, of course, because everything which is standardized will be available in DATEX and vice versa. And so again, we have here the traffic regulation. I always have here this at sign in before, because of course there is a lot of things in the model, all the things you saw before: situation, publication, measured data, VMS, all that's in, of course. I do not repeat that here. The meaning is in version 3.2 we added the traffic regulation and we added the traffic management plan. The traffic management plan, one slide for that. There are some UML diagrams on the right side, but they are more or less only for some very minor visualization. They are not, of course, not complete. There's always something missing. Of course, there's much more, of course, than these classes depicted here. But just to get a very short impression, what we are talking about. So, traffic management plan consists of 2 publications. Sometimes I'm using an ordinary wording. Sometimes I'm using the DATEX description, where you have this camel case languages, because these are DATEX objects here. The TM plan table publication and the TM plan operation publication are inside this model. And as the name already suggests, we are talking about traffic management plans. And we are dealing with things like scenarios, strategies, and then on the level of measures and actions. You know that there is some, I always call it like some theoretical framework when to activate some actions and when to deactivate actions, and that you can do with this model, which means there is no actual real traffic content in, because it's only dealing with all these things, and at the very low level, of course, existing things are reused, which are the operator actions at the end. So the model itself is only some theoretical framework. And of course, you can inform on the status and the status change of these elements. This one is under revision. I said that before. In the NAPCO project, we are right now working on a new version to improve things that can be improved. Okay, we had new in this version the energy infrastructure, and together with facilities. I said before, maybe facilities, I don't have extra slides for that, but facilities is also a quite important thing. It came up when developing energy and parking model, and the idea was that there are a lot of common elements, because when you are talking about infrastructure sites or when you're talking about parking sites, they all have the same things. They have opening times, they have rates, of course they have a location, they usually have a name and whatever, and maybe associated infrastructure around, etc. So it's all the same, and so it made sense to, in nowadays, to outsource all these elements in a own data model, in an own namespace at the end. In DATEX 3 we are talking about namespaces, which is called facilities here. And that's why I make it a little bit smaller and attach it here to this energy infrastructure element. Well, the energy infrastructure, of course, it's a very modern theme, a very important theme. Of course, the main aspect is the electric energy in this case. But right now here we also support the old-fashioned energies. You can define petrol stations that sell quite ordinary gasoline or petrol or whatever. Hydrogen is included. That means you can distinguish all these modern or more or less modern sorts of fuel and energy you like. And It's called infrastructure because you have got, again, 2 publications. The first one is that you define actually the sites where you can get these things, where are the e-mobility charging stations located. It's always it's always hard to combine this with parking, because we always face the problem that you want to define a parking site that has an e-charging station adjacent, or the other way around. You have an e-charging station and want to declare that there are 2 parking spaces. So this is always hard to have these models in combination and how to use it best. But of course, DATEX is also very much focusing on the dynamic information, of course. And so the main information is, are these things available? Are these stations in operation? Are they free? More or less, the reservation theme is another theme, but you can also define some slots when they are reserved or not. Of course, the prices and the faults, you can all define this with this model. And especially for the electric charging, of course, there is a couple of things to describe these stations, the connectors and the different charging types and the communication between vehicle and connector or electric charging station, etc. All this can be described, of course. Right now we have an activity to, this part is ready, this part is standardized, as I said before, and it's here in the DATEX model. But right now there is some analysis with the R4 model from the European Commission, the next type of regulation in this area, and we have a look if all these elements are available in the model. Rerouting management enhanced. This was one of the things which came in by this Working Group 17 project team. Rerouting management enhanced is an updated version of the traditional rerouting. There is from DATEX, from the current past, there is a actually quite small model on rerouting, and that was not sufficient, and so there was a development of an enhanced rerouting with more possibilities, where you can weight your different routes and so propose them for navigation systems, or give the information that, for example, half of the trucks should use this route and the other half of the trucks should use another route, for example, like this. All this can be done with rerouting management enhanced. It's about original routes, alternative routes. It's about triggers for which vehicles this should affect. When you are going from town A to town B, it might affect you, but when you are driving to town C, you are not affected by this rerouting. These are things you can define and specify. And also this part is currently under revision to have the latest needs for it and to make it fit for the future. You also have enhanced management measures on the route. For example, you want to specify a green wave on the alternative route, or extra lanes, or the change of direction of some lanes. You can also do that with this model. Traffic signals. Maybe you remember that was this part where we said we have to decide the future of this part. This part is a DATEX representation of this ISO 19091 and its European profile, which is commonly known as SPAD map. So signal phase and timing, the SPAD, and map, of course, the map for intersections, the digitalization of maps. And you might know that there is a quite common and quite known ISO norm that defines these things in ASN1. And in that project team from Working Group 17, they made a more or less one-to-one DATEX representation of this model. It's nice to have, but right now we are not sure how much it is used, and so there are discussions how to proceed with that. Yeah. And from the content side, you can define here the traffic signals and the dynamic information. So what are the next proposals for this traffic light? When is it intended to become green and red? And of course, the map is the static information which defines all these traffic segments and these traffic streams on the intersections. Then we have a couple of smaller extensions. To be very precise, some of these things are technical, also an extension, but that doesn't matter here on this slide. We have some more or less smaller extensions, yeah, for the common element, for the location, for urban, and for GNSS. Which means, I think Bart mentioned it, if you don't ever have heard the word extension. Extension is a mechanism to give additional features in the model which are currently not in, and you don't want to make a new version which is not backward compatible, for example, then you can extend it and give the possibility to use it for everyone who knows this extension, and the other ones who don't know this extension don't care simply about it. Yeah, and there have been the need to have some extensions. For example, in location there is some address information new. Urban extensions have been implemented. That means we have, of course, DATEX has a number of enumerations, and in the urban context, a lot of elements have been added which have not been before there. Okay, I colored some of these elements a little bit more dark, which means that they are we published them on our website, you can download them, but there is some kind of health warning that they might change in future, especially those which are under revision anyway. So you must be aware in the future there should come a new version, which is then the final version in version 3 for these elements. In version 3.3, actually there was only one new element coming into place, which was the parking. Of course, parking was there before, because parking has a quite long history, but it has a status of extensions or approved extensions or whatever. And in version 3.3, then the new parking from the new 2022 standard came into place. That means this is a version from this year. And the parking model was included there. I can tell something here about parking, which is of course a good news, but the even better news is that we have a complete session on parking, and if you're interested in that, you can learn more on that in this session. The important idea in parking is that it has a structural change behind, because there was a decision to focus on this model from the APDS, the Association for Parking Data Standards, because they came and raised a parking model in a quite efficient and fast timing, and even go into standardization on this ISO TS 5206 part 1. Also very fast. This standard, I thought it was already published, but when I looked up, it's not yet published, but it's on a quite good way to become published. And so they made a parking model. Actually, some of the people who worked on that model had DATEX experience, and that's why they used DATEX mechanisms, which is of course quite good. But they had their own intentions and made some complete new structure. And then there was a high-level DATEX decision to follow this approach and at least to harmonize as much as possible and to reuse core elements of this model so that these standards are more or less aligned. Of course, you cannot take your data from the one standard and put it to another. That will not work, unfortunately. But nevertheless, the main elements and the main core components you will find in both models, and much things are reused on both sides of these models. And that's why you find here some terms which you might have never heard when talking about parking. Maybe you have heard things like parking site, group of parking sites, parking area, or whatever. You won't find those terms in the model. You will find terms like campus, place, subplace, and yeah, these things you can see here, which is a more generic approach. And yeah, it's another concept than the model was before. Yeah, I think I didn't lose a word what you can do with it at the end. Of course, it's about specifying parking places and describing them in a very intensive manner with everything you need to know about this space. It's urban parking, it's interurban parking, it's also truck parking, which is also very important. Bart already mentioned it. And there will be a truck parking profile, which means you can define truck parking with this model, but the profile should make this more clear which elements are to be used for that when you want to do so. Because of course there are regulations which are in place and we have to fulfill them, and yeah, truck parking is one of the essential things, but you can also do urban parking, car parks, or whatever you like. So that have been the versions up to now, the models we have in our DATEX ecosystem. What's new in version 3.4? We have the status and fault model. I mentioned that in the standardization section. Yes, I have a slide for that. Yeah, as I said before, this is an enhanced model on status and fault information messages. It will be under revision. This picture might not be the most current one. There might be changes to this because right now we are working on a better model for that. Of course, it's for the communications between central stations, but it also covers all kind of field devices. When your traffic signal gets broken, or when a barrier is malfunctioned, or whatever, everything you can describe with this enhanced model on its status and on its fault. And you might remember that was the model which has an outstanding standard number, and we are trying to integrate it into our series now. And now, I think it's more or less the last one. That's more or less the things maybe you are waiting for that. And maybe you noted that I spared it off because we already mentioned traffic regulation because it was in the versions before, but I did not talk too much about it. Now I do. We have these two models on traffic regulation, and this one will become updated in version 3.4. And we have a new model on controlled zone, which will be added. And for these two models, I have extra slides. Okay, yeah. So what does the controlled publication do? The controlled zone publication, more exactly. It makes use of the traffic regulation. So this is the kind of base which is used by this controlled zone publication. And well, then you are able to model urban vehicle access regulations, UVAs, which you might have heard of. This is the context of these three elements and these three things. So what we are talking about, yeah? At the end we are talking about traffic regulations and especially traffic regulation orders, which force these traffic regulations coming into place. Yeah? More or less, to say it a little bit more simplified, we are talking about sign setting, but issued from competitive authorities. Of course, we have something like the VMS publication, yeah, but that's not the same, because VMS publication does not say that this is a real traffic regulation order which is set up. It only says there is some sign, yeah, there can be Mickey Mouse on this sign, yeah. It's something different here with the traffic regulation model. And in this case, you can also use it to model your vehicle access restrictions with the traffic regulation order class, of course, and using these traffic regulation orders. So what is the content of this traffic regulation order? You optionally have a legal basis. That means, yeah, name, version, date of the legal document, if you ever have that. Of course, you need some implemented location, validity, and then, of course, you can attach the traffic regulations. Yeah? So the order as such is a more formal element, and then the traffic regulation may follow. Some very elementary logical set to combine these things we are talking about. It's called the condition set, which was developed in the context of this model. And what you can see here is that you have several conditions of several types. Yeah, you have got location conditions, validity conditions, and you can combine them in different manners. You can combine them in the AND form, you can combine them in the OR form, and you can also exclude conditions so that yeah, you can get everything you want at the end. Because you might know that when you see signs, yeah, they are complex like this. Yeah, sometimes you have signs with 3 minor signs below which say but not at, but at, and in between, and never then, and so on. Yeah, you might have seen those signs before. Especially on the conditions, you can go on this section on conditions, which is provided in this context. Yeah, you can see here we have something about roads, about occupancy, on drivers, access, location, whatever. So a number of conditions you can yeah, set in a logical manner together to get whatever you need. Especially now the urban vehicle access regulations. This is a model which was developed in the UVA Box project funded by the European Commission. It's finished now, and there have been DATEX drafts developed in this project. And especially the last one, the third draft of this project, was yeah, more or less the final outcome, which was handed over now to the DATEX NEPCOR project and to our activity here. That means now it's our task in the NEPCOR team to bring that into our DATEX world and into standardization. And that's why this model will come into force in 3.4. And yeah, actually it's two-folded, as you already got the information. It's the traffic regulation model and the controlled zone model that is essential to really be able to model UVAs. Of course, well, it's mentioned here, but it's kind of a natural thing that other things are reused, especially the common elements and the location referencing, of course. Yeah, that's for sure. You need those things also here for modeling traffic regulations. It's also the possibility to use the rates. Rates actually are coming from the APDS parking sector. They are located in the facility package, and you can also use the rates because for those urban vehicle access restriction zones, you might want to define rates. Here I copied some slides of the UVA Box project, as you can see here. Well, it's a kind of example here, yeah, the low emission zone in Amsterdam with corresponding signs, you can see here on this slide. And you see a couple of exemptions, and you can see here the operators. You are allowed and you are not allowed, and you must have this emission class or whatever. And things like that you can implement with the model. And even more, you can, the UVA box also defined a tool which asks for all the necessary elements and then creates a DATEX output for this zone. And here you have got some picture how these things fit together. You have the traffic regulations, but of course not every traffic regulation must be a controlled zone. On the other hand, usually a controlled zone makes use of traffic regulations. And then you have the legal context here for the UVA, and you can support the information with these permits and administrative infos, etc. Well, the bad news is I'm not an expert on UVA, but the good news is that you can learn more on traffic regulation and UVA and these things in our sessions on the afternoon. Okay, yeah, here I wrote on a slide which are the elements of a UVA, typical elements. Of course, you need some general information, some description. Of course, there's probably the name of your city or town, wherever you are located. Classical broad classification, some traffic signs, and then, of course, the traffic regulations is, of course, a very important point. The location in different flavors, the hours of operation, who is affected, who is exempted, some penalty if you do not follow this regulation, the ordinary tariffs to get in, and so on. So this is a list of, there's also UVA box project also created some kind of survey where you can check if you have all this information ready of what you need to make a correct model. The model as such in DATEX has got the control zone model, which is a new one right now, has got two publications, a control zone table, so a table I told before from database point of view. You can add a number of things here to publish them, and then you can activate them using this activation publication. You can activate either predefined or ad hoc conditions. So it's your choice if you want to have a list which is already existing and then you activate it, or you do it in a ad hoc manner right on the flow. Yeah, and then you have got here some other information. A control zone may be implemented by a traffic regulation order. But on the other hand, a control zone can describe the control zone as well as alternative mobility options. And you also can, if you're not implemented by a traffic regulation order, then you can also define it as control zone regulation instances. And you have something for penalties also. Yeah, then in the control zone models, a number of conditions. I showed you the list of conditions before, but especially for UVAs, there are some conditions coming on the top, and you can see them here. Retrofitting condition, non-codable condition, traffic condition, and period condition. These are conditions which are added in terms of this new model here. Yeah, that was my last slide. And I encourage you to go deeper into the details on parking, on version 2 to 3, on this control zone and traffic regulation, everything you find in the program for today. Thank you very much.
Thank you, Jörg.
Yeah.
It was, I think, good. You see, the thing is growing and growing, and one of our challenges is how to keep this digestible for the audience, and that's one of the main topics for tomorrow's discussion. I think about the future, how to keep it digestible. The coherency is unchallenged. That we need the coherency between all the use cases that we support, but nobody is interested in all use cases. So we have to bring focus also in our offer to the users.